1. Pythagorean theorem in a right triangle. The square of the hypotenuse is equal to the sum of the squares of the other two sides. 2. Fundamental theorem of algebra. Every non-constant polynomial equation with complex coefficients has at least one complex root. 3. Law of sines in any triangle. The ratio of the length of a side to the sine of its opposite angle is constant. 4. Law of cosines in any triangle. The square of a side is equal to the sum of the squares of the other two sides, minus twice the product of their lengths and the cosine of the included angle. 5. Mean value theorem. If a function is continuous on a closed interval and differentiable on the open interval, then there exists at least one point in the interval where the instantaneous rate of change is equal to the average rate of change. 6. Binomial theorem. It provides a formula for expanding powers of binomials. 7. Fundamental theorem of calculus. Establishes the relationship between differentiation and integration. 8. Euler's formula. It relates exponential functions, trigonometric functions, and imaginary numbers. 9. Fermat's last theorem. It states that no three positive integers a, b, and c can satisfy the equation a n b n c n for any integer value of n greater than 2. 10. Fundamental theorem of arithmetic. It states that every positive integer greater than 1 can be expressed as a unique product of prime numbers.
11. Cauchy-Schwarz inequality. It states that the dot product of two vectors is less than or equal to the product of their magnitudes. 12. Pigeonhole principle. It states that if there are more pigeons than pigeonholes, then at least one pigeonhole must contain more than one pigeon. 13. Bayes' theorem. It describes the probability of an event based on prior knowledge of related events. 14. Rolle's theorem. It states that if a function is continuous on a closed interval, differentiable on the open interval, and takes the same values at the endpoints, then there exists at least one point in the interval where the derivative is 0. 15. Taylor series. It represents a function as an infinite sum of its derivatives at a single point. 16. Archimedes' principle. It states that an object submerged in a fluid experiences an upward buoyant force equal to the weight of the displaced fluid. 17. Euclidean algorithm. It is used to find the greatest common divisor of two integers. 18. Law of large numbers. It states that as the number of trials in a probability experiment.
19. Fundamental theorem of similarity. It states that if two triangles are similar, their corresponding sides are proportional, and their corresponding angles are congruent. 20. De Morgan's laws. They describe the relationships between logical negation, conjunction, and disjunction. 21. Fundamental theorem of calculus. It establishes the relationship between differentiation and integration. 22. Pascal's theorem. It states that if a hexagon is inscribed in a conic section, the points of intersection of the opposite sides lie on a straight line. 23. Law of exponents. It provides rules for manipulating expressions with exponents, such as product rule, power rule, and quotient rule. 24. Law of reflection. It states that the angle of incidence is equal to the angle of reflection when a light ray reflects off a surface. 25. Fundamental theorem of linear programming. It states that for a linear programming problem, if an optimal solution exists, it will always occur at a corner point of the feasible region. 26. Fermat's little theorem. It states that if p is a prime number, then for any integer and not divisible by p, AP11 mod p. 27. Law of total probability. It states that for any event A and a partition of the sample space into mutually exclusive events B, 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 the probability of event A can be calculated by summing the probabilities of a given each partition, multiplied by the probability of the partition. 28. Simpson's rule. It is a numerical method used to approximate the definite integral of a function. 29. Abel's summation formula. It provides a way to evaluate the sum of a series by relating it to the values of the terms and their differences. 30. Lagrange's mean value theorem. It states that for a function that is continuous on a closed interval and differentiable on the open interval, there exists at least one point in the interval where the instantaneous rate of change is equal to the average rate of change.
31. Bessel's equation. It is a second-order linear differential equation that arises in various physical and mathematical problems. 32. Fundamental theorem of projective geometry. It states that two projective transformations that agree on a line must be the same transformation. 33. Euler's totient function. It counts the positive integers up to a given number that are relatively prime to that number. 34. Principal value. It refers to the value obtained by taking the limit of a function as it approaches a point of discontinuity. 35. Jordan curve theorem. It states that any simple closed curve in the plane divides it into exactly two regions, an inside and an outside. 36. Contraction mapping theorem. It guarantees the existence and uniqueness of a fixed point for a certain class of functions. 37. Laplace transform. It is an integral transform that converts a function of time into a function of a complex variable. 38. Poincaré conjecture. It states that every simply connected, closed, three-dimensional manifold is homeomorphic to a three-sphere. 39. Analytic continuation. It extends the domain of a given analytic function beyond its initially defined region of convergence. 40. Ramsey's theorem. It states that in any sufficiently large system, a certain type of order must emerge, even in the presence of disorder. 41. Taylor's theorem. It gives an approximation of a function by evaluating its derivatives at a single point. 42. Fundamental theorem of symmetric polynomials. It states that any symmetric polynomial can be expressed as a polynomial in the elementary symmetric polynomials. 43. Cauchy's integral formula. It relates the values of a complex function inside a closed curve to its values on the curve. 44. Law of large numbers for independent random variables. It states that the average of a sequence of independent random variables converges to the expected value as the number of variables increases. 45. Lagrange multiplier method. It is used to find the extrema of a function subject to equality constraints. 46. Goldbach's conjecture. It states that every even integer greater than 2 can be expressed as the sum of two prime numbers. 47. Dirichlet's theorem. It guarantees the existence of infinitely many primes in certain arithmetic progressions. 48. Carathéodory's extension theorem. It extends a measure defined on a semi-ring to a measure defined on a sigma algebra. 49. Minkowski's inequality. It provides an upper bound for the p-norm of the sum of two vectors in Euclidean space.
50. Weierstrass approximation theorem. It states that any continuous function on a closed interval can be uniformly approximated by a sequence of polynomials. 51. Chebyshev's inequality. It provides an upper bound on the probability that a random variable deviates from its mean by a certain amount. 52. Hensel's lemma. It provides a method for lifting solutions of a polynomial equation modulo prime powers to solutions modulo higher powers. 53. Sylow's theorems. They describe the structure of finite groups by analyzing their subgroups of prime power order. 54. Bazout's identity. It states that for any two integers, a and b, there exist integers x and y such that x by is equal to their greatest common divisor. 55. Mobius inversion formula. It expresses the values of an arithmetic function in terms of the values of its inverse. 56. Green's theorem. It relates a line integral around a simple closed curve to a double integral over the plane region bounded by the curve. 57. Lagrange interpolation. It provides a method for constructing a polynomial that passes through a set of given data points. 58. Riemann hypothesis. It conjectures that all non-trivial zeros of the Riemann zeta function lie on a certain line in the complex plane. 59. Stirling's approximation. It provides an asymptotic formula for approximating the factorial function. 60. Dirichlet convolution. It combines two arithmetic functions to produce a new arithmetic function. 61. Cayley's theorem. It states that every group is isomorphic to a subgroup of a symmetric group. 62. Hermite interpolation. It extends Lagrange interpolation to include the values and derivatives of a function at the given data points. 63. Paul's marriage theorem. It characterizes when a bipartite graph has a perfect matching. 64. Liouville's theorem. It states that every bounded entire function is constant. 65. Hilbert's Nullstellensatz. It establishes a fundamental connection between polynomial equations and the ideals of polynomial rings. 66. Brouwer's fixed-point theorem. It states that any continuous function from a closed ball to itself has a fixed point. 67. Gershgorin circle theorem. It provides bounds on the eigenvalues of a square matrix based on the location of its diagonal entries. 68. Bell's theorem. It states that certain predictions of quantum mechanics are incompatible with local hidden variable theories. 69. Morley's theorem. It asserts that in any triangle, the intersections of adjacent trisectors of its angles form an equilateral triangle.
70. Gauss's theorem, also known as the divergence theorem. It relates the flux of a vector field across a closed surface to the divergence of the field within the region enclosed by the surface. 71. Pigeonhole principle. It states that if there are more pigeons than pigeonholes, then at least one pigeonhole must contain more than one pigeon. 72. Merton's theorem. It provides an asymptotic estimate for the sum of the Mobius function up to a given number. 73. Dedekind's theorem. It characterizes the ideals in a ring of algebraic integers in terms of their factorizations. 74. Chinese remainder theorem. It states that if two integers are coprime, then there exists an integer that is congruent to both of them, modulo their respective factors. 75. Sierpinski triangle. It is a fractal shape formed by recursively subdividing an equilateral triangle into smaller equilateral triangles. 76. Galois theory. It studies the relationship between field extensions and the symmetries of their corresponding polynomial equations. 77. Ramanujan's identity. It is a highly intricate mathematical identity involving infinite series and modular forms. 78. Kruskal's algorithm. It is a greedy algorithm used to find a minimum spanning tree in a weighted graph. 79. Burnside's lemma. It is a combinatorial tool used to count the number of distinct orbits under the action of a group. 80. Egorov's theorem. It states that a sequence of measurable functions converges almost everywhere to a limiting function on a measure space, except on a set of arbitrarily small measure. 81. Johnson-Lindenstrauss lemma. It states that a set of high-dimensional points can be embedded into a lower-dimensional space while approximately preserving pairwise distances. 82. Weierstrass factorization theorem. It states that any meromorphic function can be expressed as a product of simpler meromorphic functions. 83. Perron-Frobenius theorem. It provides conditions for the existence and properties of the dominant eigenvalue and eigenvector of a non-negative matrix. 84. Eisenstein's criterion. It is a test to determine whether a polynomial with integer coefficients is irreducible. 85. Fabini's theorem. It allows the order of integration to be interchanged in a double or triple integral over a region in Euclidean space.
86. Newton's method. It is an iterative method for finding the roots of a function by successively improving an initial guess. 87. Lucas-Lemmer test. It is a primality test specifically designed for testing the primality of numbers of the form 2n1. 88. Euler's formula. It relates the number of vertices, edges, and faces of a polyhedron V, EF2. 89. Riemann mapping theorem. It states that any simply connected domain in the complex plane can be conformally mapped to the unit disk. 90. Koenig's theorem. It establishes a connection between the maximum matchings and the minimum vertex covers in a bipartite graph. 91. Lindemann-Weierstrass theorem. It proves the transcendence of E and pi, meaning that these numbers are not solutions of any non-zero polynomial equation with rational coefficients. 92. Ramsey theory. It studies the emergence of order within large and disordered structures, particularly in combinatorics and graph theory. 93. Bombiri-Vinogradov theorem. It establishes an average estimate for the prime counting function in arithmetic progressions. 94. Wiener's attack. It is a method used to factorize large integers by exploiting weaknesses in the encryption process based on weak private key generation. 95. Zariski topology. It is a topology defined on the set of prime ideals of a commutative ring, which is used in algebraic geometry. 96. Artem's reciprocity law. It relates the solvability of certain congruences to the existence of certain quadratic field extensions. 97. Schroeder-Bernstein theorem. It states that if there exist injective functions from A to B and from B to A, then there exists a bijective function between A and B. 98. Perron pseudoprime. It is a composite number that satisfies a certain congruence relation involving the Perron sequence. 99. Legendre's conjecture. It conjectures that for any positive integer n, there exists a prime number between n2 and n12. 100. Sylvester's problem. It asks for the largest number of regions into which n planes can divide three-dimensional space.